Okay, so something that I didn't say on that last video, which I meant to, but notice what's happening here with this behavior. So remember back again in your algebra stage where you had the same degree. Anytime you have the same degree in the top and the bottom, then your leading behavior, right, 40 over 10, that is going to be that asymptote. That's your horizontal asymptote there at 4. So this is also your horizontal asymptote here at 4. It doesn't matter if you're going to go to positive or negative infinity. This is just proof as to why that leading behavior, that's going to get you that horizontal asymptote here of y is equal to 4. All right. What happens if I have something that's a little bit different, like this one? Where I know that h of x here is x cubed minus 2x plus 1 over 2x plus 4. So now my numerator is bigger in degree than my denominator. All right. So when that happens, right, you're always looking at the highest degree in the denominator anyway, but you're looking for that highest degree. So your highest degree here in my denominator is just going to be this x. And notice this is 2 bigger. So whenever we were in algebra again, I'm just going to keep referencing that. Back when you were in algebra again, if it were 1 degree higher, you had that slant asymptote, which is what we're going to talk about next. But for now, I want you to see what this looks like. This is more than 1, and then we know, okay, there's no horizontal asymptotes because it's more than 1 degree, all of that. So we knew that back at the time. However, now that we have this, we're going to talk about why that is, right? So here's the proof as to why in algebra we said, oh, you don't have a horizontal asymptote or a slant asymptote at all. Here's the reason why. So you're always going to take that highest degree from the denominator. Let me write this out. Minus 2x plus 1 over 2x plus 4. And that's what I'm going to multiply by. So here I have the limit as x approaches infinity of, this is going to be x squared minus 2 plus 1 over, then I've got 2 plus 4 over x. All right. We know, oopsie daisy, this is over x. I think I said it, but I didn't write it. This goes to 0, this goes to 0, because those are both over x, right? So we know those go to 0. Now I'm left with x squared minus 2 over 2. Well, what happens whenever I have this x squared? What's that going to? As x approaches infinity, yes, this is going to get massively huge, right? So that's going to be massively huge over here, this infinity. Infinity minus 2, well, who cares, right? Who cares? That's still going to get you to infinity. And think back about this for just 1 second. That is way bigger, right? That numerator is way bigger than the denominator. Because my numerator is way bigger than the denominator, it just stands to reason that this whole limit is going to go to infinity. Yeah, right? So if this whole thing is going to go to infinity because that numerator is so much bigger than the denominator, whether I put positive infinity or negative infinity in here, it's going to be the same thing, right? If I were to plug negative infinity into this, right? If I make this negative and I plug negative infinity in here, I'm still, this is squared, it's going to go arbitrarily large, and I'm still going to take that to infinity. So this one has no horizontal asymptotes because my limit is infinity. Anytime your limit goes to infinity or negative infinity for that matter, there's no horizontal asymptote. In order to get that horizontal asymptote, you have to have that numeric value. Okay, so I said we were going to talk about slant asymptotes, so let's do that right here, and I want you to see what this looks like. So here's example 4. Excuse me. I have my function is 2x squared plus 6x minus 2 over x plus 1. Slant asymptote when the numerator is 1 degree. Numerator is, man, my handwriting is just bad to the bone, isn't it? Is 1 degree greater than denominator. All right, so 1 degree or greater than the denominator. That's how we know this is going down. Okay, good. So when I look at this, if I take these limits, so let's do that because this is calculus, so we're taking our limits. We're going to take the limit as x approaches infinity here of 2x squared plus 6x minus 2 over x plus 1. So I'm taking that highest degree in the denominator. So multiplying everything through by that 1 over x. And I end up with 2x plus 6 minus 2 over x and 1 plus 1 over x. Again, this is going, all these go to 0. Because this is infinity, right? Infinity right here, and this is odd, but this is a positive infinity, then this whole thing is going to go to infinity. Give me back my red. So then this whole thing is going to go to infinity over 1, which is just infinity. However, look what happens whenever I take this to negative infinity. The limit as x approaches negative infinity. I'm just going to write this out. 2x plus 6 minus 2 over x, and then 1 plus 1 over x. Right? We know that these both go to 0. But what happens when I plug in a negative infinity? Yes. So if I'm going to the right, it's going to positive infinity, and the left is negative infinity. That tells me I have a slant asymptote. Right? Because they're not finite, I know for a fact there's no horizontal asymptote. But this does give me a slant asymptote. And in order to find the slant asymptote, we kick it back to algebra and we just do long division. Or you can do synthetic at this point. Oops, I'm out of room. So we're going to go to the next page. Find the slant asymptote of this function. F of x is equal to 2x squared plus 6x minus 2 over x plus 1. I don't care how you do this. That is up to you. If you want to do the long division way or if you want to do synthetic. And we know we can do synthetic division because this is just an x. So I'm going to show you both because it's probably a good algebra review. This is where a lot of times students struggle. They're like, oh my goodness, I don't remember that part. No problem, I got you. Let's do it right here. If we have long division, I have x plus 1 on the outside, 2x squared plus 6x minus 2 on the inside. Remember, with long division, you always take that first term and then you do that division. Like you literally just divide those. So 2x squared divided by x is going to be a 2x, right? So then that is what you put here. You take that 2x and you distribute it. So now I have 2x times x would be a 2x squared. 2x times 1 is a 2x. Remember, with long division, you subtract. So I am subtracting this off. When you subtract a polynomial, you distribute. So 2x squared minus 2x squared cancels out. That's what we want. 6x minus 2x, wait, come on, black, is going to be 4x, and then you drop down that minus 2. And then you do the same thing again. 4x divided by x is 4, and then that's what you put over here. Again, you take that 4 and distribute it. Now I have 4x plus 4 minus that. So you distribute that negative sign and you get a negative 6. Pardon me. So you have negative 6 over that x plus 1 because that's your remainder. So using long division here, we can see that this is y is equal to a 2x plus 4. When you have a slant asymptote, you do not use the remainder because it's a line, right? It's that slant asymptote, it's that line. So you're always just looking at the actual line that goes with it. So there's long division. Let's review synthetic division really quick, just because, I mean, algebra is more of an issue than calculus for the most part when we're in calculus. So you have to know your algebra here. So remember your synthetic. Let me come back up here so I can remember what my actual thing even is. 2x squared plus 6x minus 2 over x plus 1. So if you remember, my goodness, sorry guys, that creeped up on me. So if you remember here, with your synthetic division, you're always going to take whatever your factor is. So that's going to be -1. I like to put it in a box over there. Some people do a division bar. I don't care. However you were taught is whatever. And then you take your coefficients. So 2, 6, and -2. You drop down that 2. So now I have 2, and then you multiply these together to give me a -2, and then you add those up. Then you do it again. Multiply those together to give you a -4, and then you add those up. This is your remainder. And then you have your coefficients over here. So y is equal to a 2x plus 4. Anytime you have division, you always go 1 degree less. So that was x squared. I have an x. And we get the same thing. Right? And I'm sure back in the day when you were taught all this stuff, if you were, maybe you weren't. And so now's a good time to learn. Here, notice what's happening. I have this 2 that I'm looking at is just dropped down because that's the 2 we have. But look, here's where this 4 comes from, and here's where this -6 comes from. That's the product. This is whenever I do this subtraction, this is the value that we get. That's where that comes from. That's where that comes from. You can see them back and forth. Good. Notice we get to the same place. It doesn't matter how you get there. When you're asked to find a slant asymptote, 1 degree greater. Your numerator is 1 degree greater than your denominator.